Okay, stats. The other day when we were together, we started the Skittles project after filling out our formula sheet. And we did this first proportion section together really, really, really super fast, like right at the end of the period before the bell rang. But here's the data that we got when we gathered our Skittles, or when we ate our Skittles, whatever, that's all the same data. And then for proportion wise, we looked at total orange, okay? And then we did critical value method, we did p-value method, we did confidence interval method, okay? Now, I'm going to go down here to, hopefully you guys are all at this same spot, but down here to this middle, I guess like the last question on the second page, and we're going to fill this in using some different data, okay? And so I'm going to pick on Daniel because Daniel had, for his red Skittles, he only had 7 red Skittles out of his whole bag, okay? Which was like significantly less. I think there was some other people that had 7 like of each color, so I don't know, we could have done Chase's orange, or we could have done like Jalen's yellow, or we could have done Clay and Maddie's purple, but I just picked red because I like the red color. So, having few reds, I would be kind of upset, So Daniel had 7 reds out of 59 total Skittles. So let's talk about what that is going to do to our number here. So the number of red Skittles that appeared in Daniel's package was significantly less than others. All right. The number of Skittles that he had in his pack was 59. So we're not doing the total number here, like total orange, which would have been like 1,011 or something like that. We're doing just for Daniel's Skittle pack. The number of red Skittles was 7, which is going to give us a p-hat value of whatever 7 over 59 is going to be. Okay. And I don't know. 7 over 59 is 0.119, let's say. Okay, 0.119. That's my p-hat, okay? So now we're going to do the same process again, but if you remember from before, the proportion of any colored Skittles should be 20%. They say this right here, okay? Any colored Skittles should have 20% represented in each bag, okay? So we have equal to 20%, not equal to 20%. We're going to claim that they are all equal to 20%. So this one is like less than 12%. So do we think less than 12%, like 12% is close enough to 20% to say that like Daniel's Skittle pack was equally represented in color? I don't know. That's starting to get to be a low number. I don't know. So we're going to do this method. This one's going to be two-tailed. And I'm going to let you finish the rest of this by yourself. But I want you to do first critical value method. We got 2.5% here. 2.5% here and 2.5% here, which makes 95% in the middle. So critical value method for the first one. Okay, this process is going to be similar to critical value method that we did here. Okay, then you have p-value method and confidence interval method. Okay, then it asks for some questions. So like this first one, does Daniel appear to have an equal proportion of red Skittles, in his pack? Does he have the right to be mad about his lack of red Skittles? Okay, so basically based on the information, okay, when we have our two tails, like 20% would be in the middle here. If I end up with my data outside of the 20%, which I guess would be on the left side, because he has a low number of red Skittles, if we conclude that, nope, he does in fact have a lesser number of red Skittles than everybody else does, which is like in here, if we conclude that, no, his number actually lives over here, he would probably have a right to be upset, like he would have a right to be mad for having a lack of red Skittles because it is significantly lower than 20%, okay? So you're just going to answer that question. And then down here is a little bit of a thought process on would the results be different if we changed to one of those significant levels instead of using 0.05. So for our bell curve, we're going to look at, and you don't have to redo the whole thing, but just like go to your critical value method, and instead of doing 95% figure out what those critical values would be if you used like 90%, or if you used 99%, or if you used, what was the last one? 80%? I don't remember. 0.01. Oh, it would be 98%, I think. Let's see. Let me go back. I'm switching my fish value from to 0.01, 0.1, and 0.2. Yeah, okay. 0.01, 0.10, and 0.20. Okay, so here, this would be 0.5%, and this would be 0.5%. So this would be 99% for 0.01. This would be 5% and 5%, so this would be 90%. And then if I had 20%, that would be 10% and 10%, so this would be 80%. So if I switched and found new critical values for each one of those, would my results be different? Would I instead, cross this off and circle that one, or vice versa, which would be true? So you're going to fill this in. Do we reject or fail to reject H naught in each one of those scenarios? And then does that mean that he should be mad about his red Skittles, or not mad? Like, he should be mad if he lives in this region. He doesn't necessarily have reason to be mad if he lives in that region. Okay? Now, again, I understand that we're talking about Skittles, and who gives a dang about Skittles, right? But if this was like testing for pharmaceuticals or testing for pain medication, like, we want to see if the medication is causing a significant difference in your overall health, right? So like a significant difference would be like here or here. Is it significantly lowering your blood pressure? Are we on that side, right? So again, Skittles don't matter, but on other testing, the same procedure could be used to really do some work with pharmaceuticals and things like that. Okay, so finish that page, do the rest of those, and then if there's time left in the period, I want you guys to start on, I think I left with my sub, and you guys in Lawrence should have access to this also, the Chapter 8 review. You can go ahead and take a look at the first page, but what I really want you to, we'll probably end up going through the first page together. What I really want you to start on is these first two for proportion, okay? So try to get those two done if there's time left in the period. And that's for proportion. I mean, if there's even more time, you can do mean if you want to. Those two are mean, and then those two are standard deviation. I do have the values for mean. I think I did these X bar and S for mean. 62.67, and S is 19.48. Okay, so there's that. Calc kids. Who are my calc kids? Libby, Jalen, you guys, Haley. Is that all my seniors in calc? Angel's not in there. This one is estimating like the length of a minute. You remember we did that the other day in calc? Maybe we'll do that on Tuesday. We'll have fun, and we'll estimate a minute. But anyway, so there's mean. You can do any of those, but at least try to get the Skittles project done, and then maybe these first two for proportion, okay? Try those, and that's as far as we'll get.